Welcome to The Explainer. So today we are tackling what is honestly one of the biggest, most persistent headaches in modern enterprise architecture right now, and that's securing your generative AI workloads. We're moving totally past the theoretical stuff today to show you exactly how to block prompt injection attacks using the brand new AI Guardrails in Microsoft Defender for Cloud. We'll be zeroing in on the three main security risks out there, and more importantly, the direct mitigations you absolutely need to put into place right away. Here's the roadmap for today. We're going to quickly cover the Gen AI threat landscape, dive into those three critical AI security risks, and unpack the Defender guardrail architecture. From there, we'll hit real-time attack neutralization, exactly how to activate these AI security policies, and wrap up with securing your generative AI futures. Let's jump right in. All right, Section 1, the Gen AI threat landscape. The core issue we're facing here is that our traditional security assumptions, they are completely failing against modern, largely invisible AI threats. Just look at this number, 86%. According to recent data, 86% of organizations say they're actually satisfied with their current security measures. But man, in the world of generative AI, satisfaction is basically your biggest vulnerability. It creates this massive false sense of security against totally invisible, novel models that can just waltz right past traditional firewalls. And that complacency, it's incredibly dangerous. We have to remember that cybercriminals are savvy businessmen. The exact same sophisticated underground economy that built those massive, complex ransomware and phishing operations is pivoting right now. Threat actors aren't quitting their day jobs, They're just shifting their crosshairs to exploit your generative AI workloads. The infrastructure is already built and ready to go. It's literally just being pointed in a brand new direction. Which brings us to Section 2. 3 critical AI security risks. Because to effectively defend our environments, we really have to isolate the specific attack vectors we're up against. So here is the Gen AI threat triad that every decision maker needs to know. First up, jailbreaking. This is where attackers bypass safety filters to essentially make the AI go rogue. Second, we have indirect prompt injections, which is basically data poisoning. And third, credential theft and data leakage. This is where an attacker tricks your highly capable, but let's face it, incredibly gullible AI intern into just handing over the keys to your backend. Let's focus on what is probably the most insidious of the three, indirect prompt injection, or XPIA. The mechanics here are all about deceptive packaging. An attacker hides malicious instructions inside an external data source, like a website, a document, maybe even an email. When your AI assistant innocently goes to summarize that data, it unknowingly ingests the malicious command. The attacker has successfully poisoned the AI's memory before a single line of traditional code is ever executed. It's a terrifyingly simple exploit, and the crazy part is it happens completely under the radar of your standard security tools. So how do we actually stop this? Let's move to Section 3. The Defender guardrail architecture. This whole approach is built on Microsoft's Start Secure, Stay Secure framework, bridging your cloud posture management directly with real-time threat protection. To mitigate this, we really have to rethink our underlying tech. Legacy filtering relies on bad signatures, right? It's looking for known malicious words or snippets of code. But AI threats are conversational. There is literally no bad code to catch. Instead, Defender uses what's called latent space analysis. Think of it like looking at the AI's math, not its words. It isolates the harmful intent deep inside the model itself, blocking the attack no matter how cleverly the prompt is phrased. I absolutely love this concept. What if you could stop a cyber attack by reading the mind of an LLM query? It's such a provocative thought, but it perfectly illustrates how Defender for Cloud anticipates intent right at the representation level. It's not just doing simple text matching. It's actively analyzing the internal state shift of the model to instantly flag a malicious objective, like a do anything now jailbreak variant. The real game changer here is the architecture itself. Because it sits directly in front of the underlying AI model API, Defender acts as an agentless prompt guard. For us, that means zero heavy installations, no agents to manage. It seamlessly protects your custom applications, your Azure AI Foundry playgrounds, and even those quick little Python scripts you have running, all without adding any friction. Moving right along to Section 4, real-time attack neutralization. Let's look at how this architectural theory actually translates into runtime execution. Like, what happens during an active incident?
Well, in real time, 3 detection engines basically fire off all at once. Azure AI Content Safety Prompt Shield actively intercept those jailbreaks and cross-prompt injections. Next, Microsoft Threat Intelligence steps in to cross-reference global threat data dynamically, spotting shady IP addresses or Tor exit nodes. And then, for your autonomous agents, real-time tool invocation inspection adds this absolutely critical final layer of defense.
Let's look at this failsafe in action, because it's so cool. Say a poisoned agent tries to go off script and email sensitive files to an external server. Defender automatically inspects and blocks that tool invocation way before it ever actually executes. The user is stopped in their tracks, the security team gets an instant informative XDR alert, and a potential data breach is fully neutralized before it even begins. I mean, that is a massive relief for any SOC team out there. Which brings us to Section 5, activating AI security policies. Okay, so how do you actually deploy this? Let's walk security admins and SOC analysts through the implementation phase. Honestly, the best part of all this is how ridiculously easy it is to deploy. It's basically 4 steps. First, you navigate to Defender's environment settings in the Azure portal. Second, you select your relevant Azure subscription. Third, toggle the AI services plan to on. And the fourth and incredibly vital last step, make sure suspicious prompt evidence is enabled. Just like that, a totally vulnerable subscription is transformed into a shielded environment. Now that prompt evidence feature we just enabled, that is a massive win for governance. When an attack gets flagged, this feature captures the exact snippet of the malicious query that triggered the alert, so your analysts can actually triage and understand the attacker's intent. But crucially, and this is big, it automatically redacts any sensitive enterprise and user data from the prompt, keeping your investigations fully compliant with data privacy laws.
Plus, all of this telemetry feeds directly into Microsoft Defender XDR. This visualizes the complete incident story for you in one unified single pane of glass. So instead of wasting time chasing down some isolated AI anomaly, your teams can instantly connect the dots. You can link a prompt injection attempt straight back to a compromised user identity, or maybe an internet-exposed container that was providing a lateral movement path. The whole picture is just right there.
Finally, let's hit Section 6, securing generative AI futures. We need to zoom out a bit and talk about long-term governance, scalability, and strict regulatory adherence. To really keep things scalable across diverse hybrid cloud environments, you'll want to integrate Microsoft Purview. That handles your data security, sensitive information type classification, and e-discovery. Then you pair that with cloud security posture management. Together, they create this autonomous, agentless net that just sits there, constantly catching misconfigurations and detecting threats across your workloads. Which leaves us with one very vital question to consider today. Is your current zero-trust architecture actually equipped to detect and neutralize invisible AI memory poisoning autonomously? The threat landscape has already shifted beneath our feet. AI guardrails aren't just a nice-to-have upgrade anymore. They are the absolute new baseline. So what vulnerabilities is your AI currently exposing? Thanks so much for tuning into this explainer, and definitely go check your environment settings today.